car is driving along a straight highway at 65 miles per hour. Given that the outer radius of the car's tires is 13 inches, what angular speed do the wheels have? So maybe to start this out, I'm going to write down that I think that 65 miles per hour, I'm going to assign that the symbol V because that clearly represents a speed. I'm just going to put mph here, although that's really miles per hour, right? We also have a radius of the wheels given to us there, so that's R is equal to 13, and I'm just going to write out or just put inch there as an abbreviation for that. And then recognize that since we're being asked for angular speed, it's omega is equal to question mark. Wouldn't it be cool if we could just use this formula, V equals R omega, to solve that? And I think the answer is yes, we can. I mean, I haven't drawn a picture of this, maybe to convince us of that, but we said earlier that this V could either be the tangential speed of something that's rotating, but it could also be the linear speed of something that is rolling without slipping, which I think makes sense here. And in that sense, I can use that to say, hey, let's solve for omega, divide by R on both sides. So omega is going to be equal to V divided by R. The one thing I might like to do with this is some conversions to some more scientific units. So in that sense, if I'm thinking about miles per hour, I could maybe recognize that in every mile there's, I'm just going to write there's 1,609 meters in a mile. That's kind of, if you might recall, like there's 1.609 kilometers per mile, but since there's 1,000 meters per kilometer, I just did it all at once. And then for the hours, remember the hours is this, maybe I should have written this as miles over hours as a fraction. That's kind of what I'm imagining here. So I'm going to want to say, okay, for every hour on top, there's going to be 3,600 seconds. And recall that that's because there's 60 minutes in an hour and there's 60 seconds in a minute. So 60 times 60 is 3,600 is where I'm getting those conversion factors from. And that may be the limit of what I can do without a calculator right there. So now I'm going to turn to my calculator, put all those numbers in there, and I wind up with 29.0, and I think we're shooting for maybe a 2 sig fig answer here. So maybe if I just go out to 0.05 is good enough. That's 2 more than I know I'm trying to get to. So meters per second, I got to squeeze in there at the edge. Sometimes it gets hard to write at the edge of my screen, it turns out. 13 inches, how am I going to deal with that? Well, maybe if I multiply by 2.54, I like this one to start with when I'm dealing with inches per inch. There's other ways you could do this. If you look up other conversion factors, there's always more than one route that winds up working. But then I'm going to recognize that for a meter, I want to get this into meters, there's 100 centimeters. So when I plug this into calculator, I'm going to do 13 times 2.54 divided by 100, and all these units here clearly work out to give me some number in meters. And when I get that, when I do that on the calculator, that is, I get 0.3302, and that's actually unrounded. That's exactly what the calculator gave for this, but that's also maybe where I want it to be in terms of rounding at this juncture. I always, like I said, try to keep 2 more unless it happens to be more exact than that than what I'm shooting for my final answer to avoid round-off error. Anyways, at this point, I think it makes sense that I could take those 2 numbers and plug in 29.05 meters per second here for V, divide that by the 0.3302 meters for the R, and maybe I'll give myself a little space down here, put that into my calculator, and I get like 87.98, etc. So since we're going for a 2 sig fig answer, I think that's going to be 88. Now, what units do we do here? I think there's 2 options. I mean, it's pretty clear the meters cancel here, and you've got this per second. And so one option would be to write like radians per second in some fashion, but it is pretty customary in physics and for engineers and other branches of science based on physics for an angular speed to just leave out the radians and report it as a seconds to the -1, which is really equivalent to a 1/second and equivalent to the surviving unit here. So even though we are allowed to use the radians according to SI, this is probably the more customary choice for this situation. So there it is. That's it.